Hello everyone, welcome back. So in this video, we are going to continue to talk about 2.1 areas between curves. So if you watched the video, the last video, we talked about how to find out the area between two functions. So you're gonna find out the function that is a higher height minus the smaller height, and then you're gonna take the area from A to B. So in this way, you are able to find out the between area. But in this question, we took the integral with respect to with x because your interval A to B was on the x-axis, okay? But now I have another question. What if we are your integral, and then you have f of x minus g of x? What if the A and B is on the y-axis, right? So that's the second question we are going to discuss today. So in that case, you are going to take the integral with respect to dy y variable. So we are going to do that case in this video. So this is with respect to x because the A, B interval on x-axis, and the case we're going to talk about a little bit down. What if your interval C and D is on the y-axis? So in that case, simply you're gonna find out the same thing, the same idea. Let's say we have a many infinite rectangular horizontally, okay? And then the large rectangular minus a smaller rectangular. And then you can find out the between rectangular, which is the between area under the curve. So in that case, we are going to take the integral with respect to y, which means the C and D, that's the interval on y-axis. So therefore, you're going to find out the two function anyway. One is going to be higher. Then you're going to say that is u. So in this case, the u function is a higher when you look at the graph a little bit different way. So when you look at the rectangular horizontally, the y height is higher and then v height is smaller. So that you're gonna subtract from u and v and then take the integral from c and d or whatever the interval on the y-axis, so that you can find out the area between curve with respect to y variable. Does it make sense to you? So it's the same question. So the difference between the first case and second case, whether your interval is on the x-axis or y-axis, you're going to take a look at that case, okay? So let me show you that example, exactly what we're going to do. So here we go. And the one thing is, the difference is, in terms of the integral with respect to x, whatever the function was in terms of the x, correct? But if you are taking the integral in terms of y, I'm going to show you very soon, but the function should be written by y variable. So I will show you the case exactly with the following example. Okay, let's take a look at this. They want you to find out the area between two functions, y equal to x second. Yep, one is a quadratic, another one is 2 minus x linear. And then they want to find out the area between those two, which is that area. But wait a second, when you try to find out the area from here to here, it's not make sense because there's no height like this one. If you say the interval A to B on the x-axis, it's not really, cover. It's not really, makes sense. When you compare the height, the yellow one and the purple one, they're like the same height, isn't it? So instead of you looking at that perspective, let me show you. What if this way? You have something y equal to something, y equal to, let's say, C, and let's say this is y equal to D. In this way, when you look at the image horizontally, the purple, right, height is always higher than yellow height. Does it make sense? So in this question, taking the integral with respect to y is much better because you can compare which height is higher than the other. When you look at vertically, it's hard to compare which function is a higher height, correct? So when you look at the function horizontally, definitely the purple height is higher than orange. So therefore, we are going to take the integral with respect to on y-axis, okay? So let's find out the intersected point between them in terms of the y. So obviously, you can see that when y equal to 1, right? Oh, not this color. When y equal to 1, and when y equal to 0, so when y equal to 1, y equal to 0, this is so clear to see which one is a higher height. So therefore, you can solve it, okay? But I can see that the interval is going to be 0 to 1. So interval 0 to 1 on y-axis, on the interval 0 to 1 on y-axis, we observed that on the y-axis, on the y-axis, it is much clearer to compare which function's height is higher or lower, right? Therefore, you can see that on the y-axis, the g function height is always higher than f function. You see that? This purple is always higher than the orange one. So then we can express these function fx and gx with respect to y variable. So we're gonna do that work. So that's the background, because when you look at the interval based on the x-axis, it's hard to compare which one is a higher and lower between f and g. When you look at the y-axis interval, it's much clearer. The purple function, the linear, is higher than quadratic all the time. So therefore, we're gonna do that work. So step 1, we're gonna modify the given f of x and g of function in terms of y variable. So what that means is we have f of x equal to x to the second. It means y equal to x second, correct? So here we're gonna modify, solve for x. So if you solve for x, put the radical on both of sides. It is going to be radical y equal to x. So this is the equation with respect to y, which means f of y equal to radical y. So this is the f function, new f function in terms of y. Same thing, we're gonna do modify the g function was given 2 minus x. This means y equal to 2 minus x, we're gonna solve for x. So if you solve for x, this is going to be 2 minus 2, y minus 2 equal to negative x. In other words, x equal to 2 minus y. Okay, so I divided by negative 1. So that means now this is with respect to y. So that means you have a new g of y, which is a 2 minus y. Okay, so x equal to something means whatever you're plugging in the number into y, whatever, this is in terms of y variable. This is in terms of the y variable. So therefore, your new f function is a radical y. Your new function is, g function is a 2 minus y. So now we know from the new f and y, g of y, we prove that g height, the g function height. So now this is g of y equal to 2 minus y. This is f of y equal to radical y. So this is your new f and g in terms of y variable. Okay, and we proved that the g function is a higher. So therefore, we check that g function is a higher. Set it up from where to where? From 0 to 1. From 0 to 1. I'm going to subtract from g in this time because g function is higher than f function. And then you're going to take the integral with respect to y variable. So we're going to set it up. I'm going to make a little bit small space. So therefore, we have a 0 to 1. F is what? 2 minus y minus f is what? Radical y. So we are going to work on this. If you separate it, it is going to be everything separated. 0, 1, 2 dy minus 0, 1 y dy minus 0, 1 radical y dy. Okay. And then I'm going to subtract. We're going to take the integral. This is going to be what? 2y from 0 to 1 minus y to the second over 2 from 0 to 1. And then if you take the integral, this is y to 1 over 2. So y 1 over 2 plus 1 divided by 3 over 2 from 0 to 1. So we're going to calculate that. 2 times 1 minus 2 times 0. And then we have a 1 second over 2 minus 0 second over 2 minus. And then if you flip over, this is a 3. This is a 3 over 2 y to the 3 over, my bad. You're going to flip over 2 over 3 y to the 3 over 2 from 0 to 1, right? So anyway, once you calculate it first, this is 2 minus 0, 2 minus 1 over 2 minus 0. So there's a minus here. And then the next one, 2 over 3, 1 to the 3 over 2. Anyway, the next one is a 0. So 2 minus minus plus 1 over 2. Let me double check. And then I don't know why I have a negative here. Let me just get rid of this. So this one should be just minus. And then this one, minus 2 over 3. Are we okay? Yep, we good because everything, the rest of thing is a 0. So you can calculate this one, 5 over 6. You can change it to decimal as well. So this is how you're solving, this is how you're finding the area with respect to y variable because your interval is on y-axis from 0 to 1. Okay, so take a look at this question. So this is the second part that I wanted to introduce to you in 2.1. One is taking the integral with x-axis interval. The second case is take the integral on y-axis interval. Okay, so this is a very similar work, but a little bit of step. Modify whatever the given function, change it to the y variable function. So then you can start from there. Okay, so I'm gonna do just 2 more examples in this question. Very, 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 very similar what we have done so far. So let me take a look at the next example. So number 2. Definitely I'm gonna have a space. So let's take a look at it. Find the area. Find the area between 2 functions. So one is a quadratic, another one is linear. So we know that this is y equal to y second equal to 4x. Another one is x minus y over 2 minus 2 equal to 0. So first of all, when you look at the x-axis, it is a little bit not clear which one is a higher or lower, right? So when you look at the y-axis, you look at that. The red one is always higher than black one, correct? So therefore, your interval in this case will be between these 2 intersected. So it is going to be between here and here. your interval is going to be on the y-axis. Does it make sense? Yeah. So we're going to use that function because when you look at the x-axis, how are you going to compare when x equal to 1? Which one is a higher? Which one is a lower? It's not easy to compare. So therefore, when you look at the interval on the y-axis, it's much clear. Always, the red one is a higher no matter where you are. Red one is always higher than black one. So you're going to take the integral with respect to y variable. Okay. So what I'm saying is your rectangular, right? We have a many infinite rectangular, and then you're going to subtract the small rectangular. So rectangular exists horizontally, correct? Which means the interval C comma D or whatever exists on y-axis. So that's what I catch. So we're going to find out that interval, C and D. So to find out the intersected points, so to find the intersected point, you're going to say f of x equal to g of x. We don't know which one f and g yet, because actually we know this is going to be the f, because a linear is always higher than quadratic on y-axis. So anyway, we're going to make it equal to each other, so that you're going to solve for y. So first, the first function, y second equal to 4x, I'm going to divide it by 4 on both of sides. So y to the second over 4 equal to x. Okay, so that's one equation. Second equation, x minus y over 2 minus 2 equal to 0. So since they're going to be equal to each other, let me sub. So we know that x equal to y second over 4, just a substitute over there. So y to the second over 4 minus y over 2 minus 2 equal to 0. So once you do that, I'm going to multiply 4 everywhere. So if you multiply to get rid of the fraction, multiply 4. So this is going to be y second minus 2y minus 8 equal to 0. And then find out the factor. So one is a 4 and 2. This one should be negative, positive. So we have y equal to positive 4 and y equal to negative 2. That's your interval C and D on y-axis. So we just found out this is y equal to positive 4. And then this is intersected, y equal to negative 2. So that's your interval. Are we okay? So we're going to have from negative 2 to 4. And then you're going to have f of x minus a g of x. But in this time, we're going to convert it f of y minus a g of y, take the derivative in terms of dy. So we have to modify, okay, f of x, g of x into the y variable, g of y. So let's do that work. What are you guys going to do? So f of x, it is, let's say this is the f of x function, which is the first one. So y equal to second equal to 4x, right? So when you, we're going to solve for x. So when you solve for x divided by 4, so new f of y will be y second over 4. This is a new y. And then g of x, that one was, what was it? X minus y over 2 minus 2 equal to 0. Same thing, I'm going to solve for x. So x equal to, just solve for x equal to positive y over 2 plus 2. So new gy is y over 2 plus 2. So we know that on y-axis interval, the linear is always higher. So here we check that g of y is always larger than f function. You can actually compare, f of y, g of y, when y equal to 1, y equal to 2, always the g function height is higher. But we can see visually the linear height is higher than the quadratic function in terms of the y variable. So that's something you need to modify that. Now we're going to take the integral from where to where, right there. From -2 to 4. So now g minus, in this time, gy minus f of y, this is a correct subtraction. Correct? Because we proved that gy is a higher height. So we know -2 to 4, g is y over 2 plus 2, minus f is y to the second over 4 dy. So I'm going to separate each one. So that means -2 to 4, y over 2 dy plus -2 to 4, 2 dy minus -2 to 4, y second over 2 dy. You're going to take the integral of it. So 1 over 2, y to the second over 2 from -2 to 4, 2y, -2 to 4, minus 1 over 2, y to the third over 3, -2 to 4. Gotcha. Yeah. So now what happened? You're going to do the work. So 1 over 4, 16 minus 4, because that's a 4 square minus -2 second power. So I just multiply 2 times 2 is 1 over 4. And then this is going to be 2 times 4 minus 2 times -2. So this is first, this is the second. And then 1 over 6, y2. So y is a 4 to the third minus, so I'm going to just minus 1 over 6, y to the third minus 1 over 6, -2 to the third. So you're going to calculate each term. So 12 over 4, 8. This is a plus 4, 12. And then this is a 1 over 6, 4 times of 4 times of 4, 64. And then positive, double negative, 1 over 6, -8. So you can plugging in this information into decimal. You will get the fraction. It's going to be actually, this is going to be 3 plus 12. And then this is going to be negative, 72 over 6. So if you calculate it, what you're going to get? So let me see if I have, do I have any typo or nothing? Yeah, I have a little bit of typo. Sorry about that. That one was a 4. I don't know why I put 2. So let me just change it. This one should be 4. 4, right? And then y to the third divided by 3. So that should be 12. So this one, instead of 6, I'm going to change that, guys. 12 and 12 better. So this one is also 12. You can do it again yourself. You will get 12. So it's going to be 12. So what happened is 3 plus 12 is a 15. 15 minus 72 divided by 12 is a 6. So actually 9 is the area. We got it. Okay. So I'm simply, using like, I'm not doing any fancy technique. This is a simple work. We just been working so far. Find out the, where is it? In the on x-axis, on y-axis. So in this case, the integral is on the y-axis. So you should take the integral with respect to y. So that's why I modify f of x and gx in terms of y. So you're going to get new f of y, new g of y, then compare which height of the function is higher. So in this time, the linear g of y is higher on y-axis, based on y-axis. So therefore, you took the integral with respect to y from g minus f. Okay, so think about it. This is not really complicated function. You can do it. I'm pretty sure you can definitely do this. Okay. So let's take a look at one last example. because I want to practice with you so that you can have a better confidence. Here we go, example 3. So let's take a look at it. Determine, so one is y equal to 0. Y equal to 0 means what? It is x-axis. So y equal to 0, you're passing y 0. So y equal to 0 means x-axis. And then you have another quadratic function where y equal to second. So this is y equal to x a second. And there's another function linear, this one, y equal to 3 over 2 minus x over 2. So when you look at that, we are looking for the area that are surrounded by those 3. So where is that? The area we are looking for is here. So 1, 2, 3 equations surrounded is right there. So when you look at this, your area is not going to be existed based on the x because it's hard to compare which one is higher there. But when you look at the interval horizontally, right, it's much clear this height is always higher than quadratic. So are you following? So therefore, I'm going to do the same thing. We're going to write it. Rectangular exists horizontally. Okay. So therefore, interval, that means interval also exists on y-axis. Your interval is going to be this. So we need to find out what is this. We already know the bottom one is a 0. So 0 to c. Let's find out that number. So to find out the interval, you're going to say the interval intersected, so a little typo, intersected points can be find out f of y equal to g of y, correct? So I'm going to modify to find out new f and g. So let's find out that work first. So we have f of x equal to, let's say y equal to x a second. You're going to solve for x and then radical y equal to x. This is your new f of y. So new f of y will be radical y. Are you following? We solve for x. So f of y equal to radical x. So we are writing with respect to y variable. Same thing, g is y equal to 3 over 2 minus x over 2, correct? So solve for x. We're going to solve for x. So I'm going to multiply 2 everywhere. So 2y minus 3 minus x. And then you're going to solve for x. So 2y minus 3 equal to negative x. That means if I solve it a little bit smaller. So 3 minus 2y equal to positive x. So what does it mean? New f of, not f, this is a g. So gy equal to 3 minus 2y. Okay, so we found out the new f and g in terms of y variable, correct? So let's find out the intersected point because they are going to be equal. And then you're going to find out the intersected y. So if I solve it there, radical y equal to 3 minus 2y. So I'm going to square on both of sides to get rid of the radical. So y equal to, you're going to expand it, 9 minus 12y plus 4y second. That means 4y second minus 13y plus 9 equal to 0. So always you can find out the factor. So 4y, and then if you have a 9 and 1, find out the common factor. You can find a couple combination. So minus equal to 0. So what happened? Y equal to 9 over 4. Y equal to 1. This is your intersected points. Okay. So 9 over 4, this is 2 point something. So if you keep drawing, they're going to meet somewhere here too. But we don't need this interval. We need this line. So that's going to be 1. So this is 1. Y equal to 1 from 0 to 1. That's all I need. So this, we're only looking for the interval between that area. So therefore, we know that there keep going and going, meeting in another point, but we don't need that one. We need this one. So basically you have between area from 0 to 1, right? From 0 to 1. And then which one is a higher? The linear is a higher. So which one is a linear? Your G. So G Y minus F of Y. That's what we are doing. So plugging in 0, 1 G, 3 minus 2Y minus F of Y, radical Y, dy. So that means 0, 1, 3 dy, 0, 1, 2y dy, 0, 1 radical y dy. That's what you're going to calculate it. So 3y from 0 to 1, 2y to the second over 2 from 0 to 1. And this one we know y to the 1 over 2, y 1 over 2 plus 1 over 3 over 2 from 0 to 1. So this is 3 times 1 minus 0. Cancel. So 1 second, 0 second. And then you're going to flip over 2 over 3. Y 3 over 2. You're going to subtract 0 to 1. So again, this is a 3. This is 1. This is 2 over 3. 1 to the 3 over 2 minus 0. So final answer, 2 minus 2 over 3, right? So which is 4 over 3 with your answer. Okay. So again, in this video, we practice, okay, to estimate the area, between 2 or 3 functions, but specifically when your interval exists on y-axis, so that your whatever the variable should be expressed by y variable. So we modify the given f of x and gx to f of y and g of y so that you can find out the area. So if fy, gy is given, you don't need to modify it. In this example, we didn't given any gy or fy, so we modify them so that you need to convert every variable in terms of y, then check it out, which height is a higher based on the y-axis, so you can find out the area. So that's it pretty much. So we are keep practicing it, but I'm gonna skip this one. You can try this. Try yourself and go over how much you can. Okay, if you have any question, don't forget to participate in the discussion board. That's where you're engaging with other people, and always ask a question and help each other. So now you can finish 2.1 quiz, and we finished that. And in the next video, we're going to have a fun topic 2.2. All right. I will thank you, everyone. See you in the next video. Bye-bye.